We'll now deal with the Z-transform time delay property. In the Z-transform time delay property, basically it works like this. The Z-transform of Fn minus n naught multiplied by Un minus U naught is simply the original Z-transform. So this is the Z-transform of f of n multiplied by z minus n naught, if the expression Fn is delayed by n naught. But why is there a Un minus n naught here? So to explain, let us study these few figures. This is f of n, and we have an expression where we have from at the anti-causal side they are minus 1, and the causal side they are 1, 1, followed by 1.5, 1.5. Now Fn times Un simply wipes out all the anti-causal signal, because Un is a step function and it's a unit step function, meaning you multiply by 1. So it retains only Fn for all positive values. The Z-transform property is interesting for the delay. Only for Fn minus n naught multiplied by Un minus n naught is this property going to be true. What is Fn minus n naught times Un minus n naught? It is this circle over here, the red circle below. Now, notice that we are dealing only with unilateral transform for causal signal. So our input signal is 1, 1, 1.5, 1.5, and so on, although it is starting from time 0, 1, 2. Let us now delay this signal to n naught. So at n naught, we have 1, 1, 1.5, 1.5, and the rest. So this sequence is delayed to this sequence. Although at this point it's still causal, it is all value 0. How did we achieve value 0 at this point, even though it's causal? It is achieved through this Un minus n naught, because Un minus n naught means a step only from n naught, while before n naught it is all 0. So this is Un minus n naught. And when we have this expression here multiplying by Fn minus n naught, it basically wipes out all these signals, so allowing Fn and Fn minus n naught to look identical, ignoring the anti-causal signal. And when this is true, therefore the Z-transform is simply the f of z minus z minus n naught. So if you have some doubts, go through these examples here, where we have f of n here originally, and then we have Fn minus n naught. Basically, what you realize is that the anti-causal part is now shifted to this point here, and the causal part remains causal, of course, because it starts with n naught, but the anti-causal part has also been shifted into the causal part. And therefore, the Z-transform of this guy, which only takes the causal part, is of course different to this. To make them the same, we must wipe out the original anti-causal part through this point. So only Fn, Z-transform of Fn, and Z-transform of Fn minus n naught times Un minus n naught is this property true. For the proof, you can take a look at this equation over here. The idea is simple. You look at the Un minus n naught, and you will change the index of the unilateral Z-transform to start from n naught, and we have n minus n naught. Now we substitute n minus n naught to begin from 0, and therefore we'll reduce to this expression such that z minus n naught can be pulled out, and this becomes f of z, the original expression. So this is the time delay property. Please remember, in the time delay property, you have to be very careful. This is time delay property is only true when we have this type of signal. The whole signal is being delayed such that it looks exactly like the causal signal we have used for f of z. Thank you.